Hello team, today's challenge is blood type compatibility, where we're given a donor type and a receiver type, and we need to make sure that they are compatible so that we don't make the receiver super sick, okay? For this one, we are only testing the ABO system, not any of the other 48 different types. Pretty amazing stuff when you start reading about it. Just ABO and the RH factor, okay? So there are some rules in here and some pretty thorough tests. But the first step, at least for me, is figuring out how to break this apart. We have AB and a plus or minus, B minus, A plus, O plus, O minus, right? We have to break those apart because it's easier to test the type and the RH separately. Let me show you what that means. So right here, I'm going to create a function, and I'm going to call this split type and RH. Keep wanting to type a space in there for some reason, but right here we have our blood type, okay? And we can split it. Now you'll notice that I pasted that line in there because I don't want you to use it. So please don't type this out. It is super slow, but it is a very interesting solution. So I wanted to touch on it really fast, okay? Where we are splitting, and we're splitting based on a negative look behind, right? Or a positive look behind, sorry, and a positive look ahead. So the positive look behind looks for a letter, either A, B, or O. And the positive look ahead looks for a plus or a minus, and it splits right here, okay? We didn't add any characters in there, so it just splits on whatever is in between them, okay? Which is nothing, which means that it will return the letters and the sign in separate pieces as an array. Again, it's super slow in my testing. This was like, I want to say, at like very slow. I'll show you in a bit here. Okay, so let's do the second part. Return. In this case, we take BT, we slice it. It's all grayed out because I did not comment this out. There we go. We slice it from 0 to -1, okay? And then, of course, BT dot slice again, grabbing -1 to the end. We don't need another thing for that because it will just go to the end. So it grabs really there's only one character there. But at this point, we grab everything up to and including the last character, and then we grab the last character to the end of the string, which is one character, right? This is a way faster solution. And to prove it, over here, I set that up exactly like that. So here's our regular expression. Here's our slice. And you can see that slice is 104 million ops per second compared to just 200 million ops per second. So hugely fast, very big difference. And I wanted to call that out. I like this. I think it's a very elegant solution to use split, but I'm not using it today because it's slow and I want to be a little bit fast on this one. So going back, we have done that. It's going to return an array with our type and our RH, okay? We can use that down here. So destructuring a little bit, we're going to get the donor type and the donor RH like this from here. We're just going to grab this, copy it down, put in donor just like that, copying, pasting for the win, changing this to an R and this to an R. Could have used multiple cursors there, but I missed it. Recipient, brilliant. So we have these pieces. Now that we have these pieces, we can test against them. And again, it's easier to test them individually because the plus and minus versus the blood types themselves are separate from each other, okay? Together, they work as a whole package, and you need to be aware of that, but we can test them individually. So first up is the RH factor, okay? That's here. Function is RH compatible. There it is, okay? We're going to pass in the DRH like this and the RRH, so the donor and the receiver just like this, and we can return a true or false statement. That true or false statement is really only concerned about one specific case, and that's the donor is a plus and the donor is, yes, a plus and the receiver is a minus. That's the only time it's not compatible. The only time. Think about it. If it's plus plus, those are the same, that's compatible. Minus minus, those are the same, that's compatible. And if it's minus plus, then it is still compatible. Okay? So the only one we're concerned with is when it's plus and minus, and we can do that right here. So DRH equals a plus, and just like this, RRH equals a minus, okay? But is RH compatible? We want this to be true if these are false. So in order to flip this around, we do exactly that. We add a bang or a exclamation mark to the start, okay? And then we test against these. If this is true, we flip it to false and kick it out the door. For everything else, this will be false. We flip it to true, kick it out the door, okay? So this will get us our true or false based on the RH value. The second one is the function for type. So is type compatible, okay? Typo. Little Freudian slip there? I don't know, but here, compatible. Brilliant. We have the donor type and the receiver type, right? So similar sort of thing where we return a true or false statement based on whether these work. The first one being the donor type. Is it an O? Just like this. That's an O, not a 0. They look very same, so I had to double check. You probably should too, but a capital O. So if it's a capital O, that's compatible with everything. We can just return it as true. Or the receiver type, okay, includes, just like this, donor type, okay? Not like that. It needs to be in brackets, okay? Or parentheses, sorry. So the receiver type includes donor type. Let's think about this for a second, okay? That O, if this is true, it's going to return true, problem solved. If it's not an O, it means that it's either A or B. And in the case of A, it's compatible with A, and it's compatible with AB. Think about it. The A is in A, the A is in AB. The B is in B, the B is in B, AB. AB is obviously in AB. So if this donor type is included inside of this this receiver type, then it is true. Okay? So one or the other, it's either an O or we do this magic. And now we can wrap it up. Because I used all the same arguments, it's going to light these up as we use them. So we test against the type, and then we test against the RH value, and we're done, okay? A lot more talking than probably needed to be, but think about it. We split these up, then we tested the RH, and we tested the type separately because it's easier that way, and it's easier to test, right? If I was writing tests for these, I could test against type compatibility and RH compatibility, and if one of those was failing, then this is probably going to fail too. But it helps me debug faster, okay? And then, of course, splitting, doing a little bit of performance testing because not all regular expressions are fast, right? It's really that simple. This is a very slow regular expression, which means that doing a slice is way, way faster. Did anything surprise you on this? Did you like this solution? Did you have another one that you want to share? Add all that stuff to the comments. Otherwise, today this has been Blood Type Compatibility, and I will see you tomorrow.